Hey there! Today we are going to start looking at patterns and begin talking about inductive reasoning. So first off, inductive reasoning is using patterns to determine information, where we try and figure out something, we try and figure out what the pattern is, and we're going to use that information in order to figure out more information, figure out more parts for the pattern. So for instance, we may be asked to find the next two terms in the pattern. So if we start with 2, go to 4, go to 6, you can see that we're increasing by 2 each time, or our first term, 1 times 2, our second term, 2 times 2, and our third term, 3 times 2. So we should imagine our next term is going to be 4 times 2, which is 8, and our fifth term is going to be 5 times 2, which is 10. So we know the next two numbers in the pattern are 8 and 10 because of inductive reasoning. All right, we are also going to be talking about conjectures, and a conjecture is an idea reached from inductive reasoning. So we've got the same pattern as before, the 2, 4, 6, 8, and we want to make a conjecture about this. And my conjecture is going to say that whatever number we have is that term times by 2. So for instance, this is our first term, and so we had 1 times by 2 to get this. And this is the second term, so this is 2 times by 2 to get 4. Third term, 3 times by 2. So the number that we have is the term times by 2. Our term number is, our number in the pattern is the term multiplied by 2, and that's my conjecture. That's what I can say about this pattern. It's something that I've learned about this pattern. All right, our last term here, we've got counterexample, and we have counterexamples because not all conjectures are correct. Not every basically guess that you have about something is going to be correct. And a counterexample is an example that shows that a conjecture is incorrect. So let's take a look at this conjecture here, and we're going to find a counterexample to this conjecture. So our conjecture here says multiplying a number by 2 will always give a bigger number. So if you think about it, looking back at the last examples we had, if we had the fifth term, well, 5 times 2, that gives us 10, so 10 is bigger than 5. And the sixth term, 6 times by 2 is 12, so that gives us a bigger number than we had before. However, this is not always true, because if I take -3, -3 times by 2 gives us -6. And we know that -6 is less than -3. -6 is smaller than the number that we started with. So this is a counterexample right here. This means the conjecture that we have here is not true. And all we need is one counterexample to say that a conjecture is not true. So if there is a single example of when this is not true, it means that our conjecture is not true.